What? 3.5 standard deviation. That's what we'll be looking at. Hello. All right, good. So I had to fix a couple things. All right, let's do it. So standard deviation, this is what I want you guys to do. Is just Google standard deviation calculator. Let me know once you all have done that. Don't use the formula. Formula is so difficult and hard. This is the symbol for a standard deviation. And basically what it means, standard deviation is a way to describe the amount of the spread that is inherent in the data set. So basically when we look at a set of data and we want to know how far they're apart, let's say you have average, what's going on from the average to the high to the low and all that. That's what's going on. That's what we need to understand. And there's a crazy equation for it, blah 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 blah. I don't care about it. We're gonna use the calculator. Let me know if you guys have the calculator ready, and we want to find out the standard deviation for these set of numbers. Which is 42, 62, 73, 75, 90. Comma, 73, comma, 74, comma, 90. And you round it to the 100th number. And I got 15.93. Did you guys get that? All right, 15.93. All right, good. So let's do some other set of numbers. I want you to practice these set of numbers. Let's say 70, 81, 37, 50, 101, 23. All right, let's look at it. 70, 81, 77, 50, 101, 23. We got 24.79. No, we're not doing pop quiz today. I'm eating food. So the day when I don't eat food is the day when I give you pop quiz. It should be 24.79. 24.79. That should be the standard deviation. Let me check my numbers. 70, 81. Oh no, my mistake. It's my error. 37, 50, 101. It is 26.52. 26.52. So the next class, should I have what is that? Watermelon? Do they have watermelon? Good watermelon now? Like really juicy watermelon, not one of those like overgrown watermelon. It just looks watermelon, but it doesn't taste any good. Same as the strawberries. In last 20 years or so, strawberry is not the same as strawberry used to be. It's all like it looks good, but it doesn't taste good anymore. Strawberry is really nasty nowadays. All right, so from that, we're gonna look at normal curve. And usually we use normal curve to describe, let's say, IQ, those type of questions. So if we have some kind of data, oh wow, Motor Month, I don't know what's your name is. Like, I don't think you guys are that old to know it. Most of you weren't even born 20 years ago. But like, if you like, ask your mom or grandpa that grandparents that strawberries of those time versus now, it's not the same. You can't even get those seed anymore. All right, so normal curve is something like this. Let's say we're talking about some, let's say some kind of data. Let's say we call it like 30, 40 on a basketball game, 60, 20, 10, something like that, and number of players. So what normal curve is, and I know it's not true in basketball, but let's say some people score like this, some people score, more people score on 20, and most people score on 30, and then it kind of goes down, and then it goes down like that. You're still a child. All right. So when we have a data set that's spread like this, this is called normal curve. And we're going to see actual usage of normal curve. But in a normal curve, in the center, let's do the normal curve. Center is the average. We call that mu. That's mu, not the Pokemon Mewtwo. And then from there, you have things going on right over here. And I'm going to tell you what they are. We'll call them standard deviation. 2, 3, 2, 3. From the mu, it goes +1. Let me zoom in. +1 standard deviation. Over here is +2 standard deviation. plus 3 standard deviation. And then so on, plus 4 standard deviation. You could do more and so on. We'll just stick to that. 1, 2, 3, that's fine. And then over here it will be minus 1 standard deviation, minus 2 standard deviation, and minus 3 standard deviation. So in terms of normal curve, how do we use this standard deviation with the average? So from the average, we want to know what one standard deviation means is we use the calculator to figure out what is this standard deviation. And then if we create a data, we know that one standard deviation away means it's plus 26.52. Oh, let's do this. What's the average of this? For this set of numbers, what's the average of that? $60.33. $60.33. So if I want to stay away one standard deviation from the average, I have to add, let's say, here's the mu, and I want to go plus 1 standard deviation. I add 60.33 plus 26.52. And if I go negative 1 standard deviation, then I subtracted 60.33, 26.52. Subtract that. And I'm going to explain to you in a bit what it means. Any question yet? All right, guys, just in case, those of you are coming in late, if we get those inappropriate comments, anything like that, I'll shut up the chat right away. All right, so let's go back to this normal curve. So in general population, this is the rule that statistician came, general population. Let's use different color. From plus 1 to minus 1, it covers 68% of the population. And if we have 68, then each region will have 34% of the population. Any question yet? No? All right. Then for the 2 standard deviation, it covers 95% of the population. So this whole region you all see, it covers 95% of the population. Now, since I've already used 68% of the population, what percent of the population do I have left over here? So one way of doing that would be 95 minus 68. Let's use your calculator, kids. We get 27. And then I take 27 divided by 2. And they'll give me 13.5. That's to represent this much of the population right over here. So I'll have 13.5%. Any question yet? All right. Some colors. All right. Now, third standard deviation covers 99.7% of the population. So I want you guys to figure out what percent goes over here. Right over here. And rest of them are 100% population. So I want you to figure out these two sections, what they are. I'll give you a minute. All right, no question? All right, so I guess you already know this will be 2.35%. 2.35%. So since I've used 99.75%, I have 0.3% left. So therefore over here I'll have 0.15%. 0.15%. Now we're going to use this table over and over again to do the following problems. Let's do some example problem, homework problem. All right, I want you to open up to the go to the page 153, 152. All right, if you want to slow down, raise your hand. Shoot me text. If you have personal question, you could ask me. Right here. All right, so let's open up the question. Let's look at number 5. And what I'm gonna do is I'm gonna copy this over and over again because we're gonna use this. Copy, boom, paste. Okay. I'm gonna erase some of this. All right, so let's look at that. You have 70, 74, 78, 82, 66, 62, 58. All right, children. Should I give you a pop quiz? You guys are incredibly quiet today. Maybe I'll give you a super easy one. Who knows? Or maybe super hard one. Well, no, I ate some food, so. All right, so let's look at that. These means the heights of the student. They mean height of the students. Let's answer the first question. What's the average for the height of these students? Oh, it's super easy. 70. That's the average. What's the standard deviation? What's the standard deviation? It changes by what? 4 inches. By the way, except for America, everybody uses those metric systems. So for height, they use meter, centimeter, and all that. And I don't understand that. All right. It confuses me like crazy. All right. Now let's look at the second part. We're looking at what percentage of the students are 62 inches tall. So we're looking at this region, and we're going up that way. So we want to know what percent of the population are 62 inches and taller, right over here. So one way of that is we could add all these numbers, or I could just add these two numbers and subtract it out of 100. And we'll get 2.5, so which is 97.5%. For D, it's asking what percentage of the population are less than 66 inches. This is 2.5. That's 2.5. That's 14, 18%. So I'm just adding all these numbers. Any question? No? Alrighty then. Now, what percentage of the students are between 62 and 74 inches tall? So now we want to know what percentage of the population are 62 and 74 inches tall. Ooh, we're looking at these region right over here. So that would be E. So 68 plus 13.5 will give you this is supposed to be one of the hardest sections, and you kids are killing it if you say it's all understandable. All right, so that's 81. All right, now the hardest part. E. What was the range in inches of the middle of 68% of the students' height? Oh, that's pretty easy. This is the middle of the 68. So we're looking at this region, and we want to know the height for the 68%, which is from 66 to 74 inches. All right, that was pretty easy. All right, let's do a hard one now. Do you have any question you want me to do on the book? From the book? Let's do number 7. Let me see. No, not 7. I want to do something else. Oh yeah, let's do number 6. 6. All right. All right, let's look at number 6. Let's create the normal curve. The score on a chemistry exam was normal distributed with the mean being 65. And the standard deviation is 9. So 6 plus 9, that would be 74. There you go. And then 83, and then 92. Then it would be 56, 47, 38. Okay. So let's answer the first one. Okay, I want you to practice. I want you to do the problem A, B, C, D, and that before I attempt it. Go ahead and start the process. I'll give you a couple minutes. Okay, let's do the first one. What percent of the people scored more than 65, which is 50%? So we're looking at average. B, what percent of the scored above 56? So we're looking at this. So 50 plus 34, which is 84%. What percent of people scored below 47? Oh, that's easy, 2.5%. What percent of the students scored between 65 and 74? Which is 34%. Now, what percent of students scored 56 and 83? 56 and 83. Again, that's pretty simple. We did that earlier, right? 81.5%. So we have, this is a tricky one. We have 1,000 students taking the exam. And all the students with grades, and all the students with grade 74 earned B. So 74 and 83 is B. How many of them student earn B? So we're looking at 13.5% of the population of 1,000. That will be the hardest one. 1,000 times 0.135. 135 students. All right. How many students how high must the student score in order to be in the top 2.5%? Oh, right over here. So we're looking at top 2.5%. So we're looking at G score of 83 or higher. All right. Any questions, anything like that with the due dates? Ask me a question. No questions? All right, I will end the lecture. I'll wait for 1 more minute on the live lecture and I'll be here on the chat. Well, will you have, when is spring break? Yeah, 3.5 is due tomorrow. Well, oh, is this quiz 3.5 due tomorrow? Oh, will we have quizzes? When is the spring break? Let me Google the spring break. This remote site thing throws me off. So I don't know when is the spring break and all that. Let's find that. Oh, it's end of March. 3.5 is due today. Oh, okay. Let me change that real quick. Um, 3.5 is due today. I thought I made it due tomorrow. Let's check it. No, it's due tomorrow. 3.5. Check it again to make sure. Yeah, it is due tomorrow. I don't know where you're getting that number from. No, 3. What? I just checked it. 3.5 is due March 5th. 3.4 is due March 4th. We finished 3.5. Did I title it incorrectly? No, it's 3.5. Yeah, I covered 3.5. It must have been like due dates. They do get changed, like starting of every week. Oh, don't worry about that. So I always update it. So when you worry about due dates, check the latest due date after start of a week when I finish a lecture, because that tells me how fast or slow we're going. All right. Any other question? All right. Okay. I will end the lecture over here, but I'll hang around over here on the live chat if you have any question.